Hello, my name is Pablo Sidler, and the title of my project is Thermodynamics in the Winds. Most wouldn't realize that the warm winds from the high mountains that blast beautiful cities around the world, for example Denver, in the fall, winter, and spring, can be explained with thermodynamic principles. The reason that cities like Denver have seen winter days that melt away a foot of snow in hours is due to the Chinook or Foehn winds. These winds are the result of adiabatic warming of air traveling over the tall mountains. For example, in Montana, on January 15, 1972, there was a total temperature change of 58 Celsius over a 24-hour period. There has even been records that show the effect of the adiabatic warming stretching from the Rocky Mountains all the way to Wisconsin. It is simply amazing the large effect thermodynamics have on Earth. In order to understand or logic through this natural phenomena, we must review basic thermodynamic principles. Begin with the relationship between the change in internal energy of a system that is equal to the heat added to the system minus the work done by the system. In an adiabatic system, there is no heat added to the system. Hence, in this situation, the change in internal energy is simply equal to the negative work done by the system. Also, one has to understand that energy is always conserved. When studying gases, we can use an ideal gas to show the trends of driving forces at play when observing real gases. For ideal gases, the work done by the system is equal to the negative pressure times the change in volume. When looking at the Chinook winds, we are talking of a system that can take up the whole volume of the Earth's atmosphere. In other words, it stays constant, so there is no work done by the system due to the change in volume. From further study of thermodynamics, we end up understanding that adiabatic work must be calculated from the heat capacity of an isobaric process, meaning that constant volume multiplied by the change in temperature. Thermodynamics will help explain the causes and effects of the Chinook winds, but the driving force behind these winds are water and altitude, not the change in volume or temperature. From studying the physical characteristics of water and air, we know that water is higher heat capacity in comparison to dry air. This physical property is the reason why the warming effect felt by the Chinook wind is even a possibility. In the mountains, for example, the Rocky Mountains just west of Denver, warm, moist air from the Pacific Ocean are forced up into the very high altitudes along the continental divide in order to complete their crossing over the North American continent. As the warm, moisture air rises over the mountains, it is cooled at about a 0.54 Celsius per 100-meter rate. Now, in comparison, dry air will cool at about a 1 Celsius per 100-meter rate. This is directly correlated to water's physical properties and the effect the heat capacity of water has on the air as a whole. As the moist air cools in the higher altitudes of the mountains, it will experience low pressure and lower temperatures that force the moist air to hit the vapor-liquid phase change and condense and fall as rain or snow on the water's western side of the peaks. Once the cold, drier air spills over the top peaks of the mountains, it will rush quickly down the other side of the mountain, while compressing and warming. This is adiabatic heating. This is how the people of Denver can see the large amount of snow practically disappear in hours, while 2 to 4 hours west of them is a blizzard or rainstorm. It is through the effects of water's concentration in the air, water's heat capacity, the change in pressure, and the conservation of energy that allows the thermodynamic relationship in an adiabatic system to cause the Chinook winds their characteristic warm breezes. Thank you, and that is the project that I developed this semester.